Here we go with our chapter 10. Chapter 10 is going to deal with radicals, radical expressions, and rational exponents. So to start off, let's just do a quick review of radicals are. So everybody's familiar with the numbers that we consider are perfect squares. So for example, 4, 9, 16, 25, those are perfect squares. 4 is 2 squared. 3 squared is 9, 4 squared, and then of course 5 squared is 25, and so on. So those are perfect squares. When we take the square root of a number x, the square root is going to be the number that is squared to get x. Now, when we talk about square roots, we are going to use this symbol. That's the square root symbol. Okay. The number inside here is the type of root we're talking about. If there's nothing there, it's going to be the square root. What's underneath is what we call the radicand. So we have the square root symbol. Here is the type of root we're talking about. Again, if it's nothing there, it's considered the square root. That we're going to call the index, and we're going to be changing our indices as we go throughout. So for example, if I want the square root of 25, the way to write that would be the square root of 25. And what we would want to know is what number, when multiplied by itself, gives me 25. Well, the answer is 5. Now, we all know that there's another number that when multiplied by itself gives us 25, and that is negative 5. But notice here we denote the non-negative or principal square root with the radical sign. So when we're given the square root of 25, we're just going to be finding the positive square root for now, which is also called the principal square root. If we want the negative square root, we're going to have something like this. We'll do negative 30, the square root of 36. So this would be negative 6. But again, if there's nothing there, we're going to be talking about the positive one. All right, so just really quickly, let's simplify these. What's the square root of 25? We know that's 5. The square root of 0 is 0. If we take the square root of 9 25ths, well, that's the same thing as the square root of 9 over the square root of 25. So you just take the square root of the top and the bottom. So we're going to get 3/5. If I want the square root of 0.36, what multiplies by itself to give me 0.36? That's going to be 0.6, not 0.06, 0.6. If I want the square root of x to the 10th, what's going to multiply by itself to give me x to the 10th? That's going to be x to the 5th. Because if I multiply x to the 5th times x to the 5th, I would add the exponents according to the exponent rules, and that would give me x to the 10th. The square root of 36, x to the 10th would be 6x to the 5th. This is asking me for the negative square root of 25, so that would be negative 5. Now look at this. This is asking me for the square root of negative 25. In other words, what number, when multiplied by itself, gives me negative 25? Well, you might think, well, it's going to be negative 5. Well, that's not true, because negative 5 times negative 5 is positive 25. And it certainly isn't 5, because 5 times 5 is 25. So for right now, until the end of the chapter, if I'm asked to find the square root of a negative number, there is no real solution. All right, so you can also find square roots with calculators. So let me just kind of show you on my calculator. The square root button is right above the x squared. I have a TI-84, which is probably what most of you have. So take a second and identify where that square root button is on your calculator. It'll usually be above the x squared or the something squared, because you always have opposite operations here. So if I want the square root of 30, in my case, you would do just second x squared 30. And now it says round to the nearest 10,000th place. So I get 5.477225. If I'm going to round to the nearest 10,000ths, this is tenths, hundredths, thousands. That's this 2. So if I go 1 to the right, that 2 doesn't change that 2. So my final answer would be 5.4772. Okay, so in each one of those, we were talking about the square root. In other words, the index was an understood 2. Let's talk about a cube root. So if I talk about a cube root, that means that my index, that's that little number, is a 3. And it means that I'm looking for what number multiplied by itself 3 times is going to give me the radicand underneath. So you can see here, since 2 cubed is equal to 8, that means that the cube root of 8 is equal to 2. So here, what number when multiplied by itself 3 times give me 64? That number is 4, because 4 times 4 times 4 is 64. Now, if it's a cube root, a negative number will have a cube root. What number when multiplied by itself 3 times gives me a negative 8? Well, the answer is negative 2, because if I multiply negative 2 times negative 2 times negative 2, that's 3 negatives, I'm going to end up with negative 8. How about here, the cube root of x cubed? Well, what multiplied by itself 3 times gives me x cubed? That's simply going to be x. How about the cube root of x to the 6th? What multiplied by itself 3 times is going to give me x to the 6th? That's going to give me x squared. So are you kind of seeing a little shortcut here? What you do is you take the index and divide it into the exponent. 3 goes into 3 once. So the cube root of x cubed is x to the 1st. Here, 3 goes into 6 twice. The cube root of x to the 6th is x squared. We'll talk a little bit more about that as we go on. How about the cube root of 1 over 64? Well, the cube root of 1 is 1. And in A, we found out that the cube root of 64 is 4. So the cube root of 1 over 64 is going to be 1/4. So if we talk in general about nth roots, if the root is even, in other words, if this is an even number, and we're taking the 4th root, for example, of a to the 4th or a to the 8th, we would usually put that in absolute values. If the root is odd, we don't have to worry about that. So for example here, and that's only when you're dealing with a variable there. So for example here, we have the cube root of negative 5 to the 3rd power. Well, that's simply going to be negative 5. No big deal. If I have the square root of negative 3 squared, that's going to be the absolute value of negative 3, because this is an even index. And by the way, that should make sense because the absolute value of negative 3 is 3, and negative 3 squared is 9. If I have the 4th root of x plus 6 to the 4th, this is an even root, so we would go ahead and make that the absolute value of x plus 6. This is a 5th root, so we don't have to worry about it. So this would be just 7x minus 1. Now this is a square root. The square root of 36 is 6, but then what we would have to do, because it's a square root and this is a variable, is we would have to put that x in absolute values. So you only have to worry about that if you're talking about an even root, square root, or a 4th root, or so on. All right, well, let's graph the square root function. I actually believe that we've already graphed this, but just in case, let's go ahead. So remember, the square root function looks like this. So if I plug in my x's, and I plug in x's that make sense here. So if I plug in 0, the square root of 0 is 0. The square root of 1 is 1. If I plug in a 4, the square root of 4 is 2. And if I plug in a 9, the square root of 9 is 3. Of course, I didn't plug in a 5 because then I'd use my calculator and that would just be an approximation. I can't plug in any negatives because that would take me out of the real numbers. So if we look at these values here, this would be the smallest value, 1, 1, 4, 2, and 9, 3. Correct me if I'm wrong, but I'm pretty sure we already graphed the square root function. It looks like that. What we haven't done, though, is we haven't graphed the cube root function. So let's go ahead and let's graph the cube root function. Well, the cube root function is going to be the cube root of x. So if I go ahead and if I make an x, f of x chart, plug in some values. Well, I'm going to plug in 0. The cube root of 0 is 0. If I plug in 1, the cube root of 1 is 1. If I plug in 8, the cube root of 8 is 2. How about if I plug in negative 1? What's the cube root of negative 1? Well, the cube root of negative 1 is negative 1. And negative 8, remember when the index is odd, you can have negatives underneath. What's the cube root of negative 8? That is negative 2. So let's see what this looks like when we graph it. So 0, 0, 1, 1, 8, 2 is going to be way out there. Negative 1, and negative 8, negative 2. The cube root function is kind of snake looking, and it's going to look like that. And there's the end of 10.1.